Okay, so welcome to the first section of chapter 10. This is 10.1, cosine of a plus or minus b and sine of a plus or minus b. And this is your sum and difference formulas for cosine and sine. I should say these are right here below. All right, and let me tell you how we memorized these identities back in the day. All right, there was this group in the, early 70s, late 70s. You may have heard of them. They were Led Zeppelin. And they had an album called The Song Remains the Same. And we changed that to The Sine Remains the Same to help us remember how to do this. So for sine of alpha plus or minus beta, in the identity over here on the right-hand side, the sign remains the same. For cosine of alpha plus or minus beta, the sign does not remain the same, but the function remains the same. So we always started cosine of alpha plus or minus beta with cosine of alpha, and then cosine of beta. All right, so the functions are the same, but now if this were a plus, this would be a minus, and if this were a minus, this would be a plus. So we write this in identity, just a minus over a plus. That tells us we're doing the opposite here. All right, and then we have a sine of alpha, sine of beta. Now for sine of alpha plus or minus beta, the function is different. So we start with a sine of alpha, cosine of beta, but then the plus or minus stays a plus or minus. Yeah, the sign remains the same. So if this is a plus, this is a plus. If this is a minus, this is a minus. And then over here we have cosine of alpha and sine of beta. So there they are. So how did we use these? Well, you guys have your key outputs on the unit circle, like 0, 30, 45, 60, and 90 degrees. And you can give me exact answers for all of those. And those are reference angles for many, many more angles too. All right? But you always don't start off with a sine of 30 degrees. So what do you do if you get stuff like this? Find the, and the key word here is exact value of sine of 15 degrees. Well, I could approximate this on my calculator, but the only way I'm going to get an exact value is if I know my sum and difference formulas for cosine and sine. So, sine of 15 degrees. 15 degrees. Let's think about that now. Okay. Well, there's our unit circle. And again, if I approximate a 15-degree angle right there, I don't know this terminal point right there. All right, that's 15 degrees, but I do not know this. Now, what do we know? Well, we know the terminal point for 45 degrees, and we know the terminal point for 30 degrees. Right there, I know the coordinates of this point and that point on the unit circle. And could I use those two angles to come up with the output of sine of 15 degrees? We can with these identities above. So we're going to say sine of, and let's see, alpha plus or minus beta and a plus or minus. So I'm going to go 45, what? Minus the 30. That would give me 15. So see this 15 degrees right here? How about 45 minus 30 degrees? Okay, well, those are equivalent. And now we think, okay, well, sine of alpha minus beta would be sine of alpha or sine of 45. And then cosine of beta, or in this case, cosine of 30, and the sign remains the same. So see this minus? Minus. And then we go cosine of the 45-degree angle times sine of the 30-degree angle. Now, you all know the outputs of each of these factors and terms here, so let's just do our arithmetic. So sine of 45 degrees, that's this vertical distance right here, and that is exactly root 2 over 2. Cosine of 30 degrees, well, that's the horizontal distance right here, and that is exactly root 3 over 2. Okay, minus cosine of 45 degrees is also this horizontal distance, root 2 over 2. And then sine of 30 degrees, well, sine of 30 degrees is that vertical distance right there of 1/2. Now let's do our arithmetic and write our exact answer. So do you see in these two terms a common denominator of 4? And then root 2 times root 3 would be a root 6 minus, And root 2 times 1 would be root 2. So the exact answer for sine of 15 degrees is root 6 minus root 2 divided by 4. And that's how we use our sum and difference formulas. Cool stuff. And the opportunity for more exact answers. All right, so now what are they going to do for us? Okay, we're going through the back door this time. Find the exact value of cosine of 50 degrees, I don't know that, times cosine of 10 degrees, I don't know that, minus sine of 50 degrees, I don't know that, times sine of 10 degrees, I don't know that. But I see cosine, cosine, sine, sine, so we're using the cosine of alpha plus or minus beta, and here's our identity up here. So let's visualize this though on the unit circle. 50 and 10, it sounds like I might be using a 60 to me. So let's approximate the terminal ray for 50 degrees. We don't know that point. And then 10 degrees, and we don't know that point. But what do we know? We do know 60 degrees, which would be right in here. And that is going to be, well, all right, the cosine of 60 degrees, this point would be a 1/2. And the sine of that 60 degrees would be a root 3 over 2. Now, can I use this point to answer this question? So let's work this way. See, cosine of alpha times cosine of beta minus sine of alpha times sine of beta. All right, so that is going to be this side, cosine of alpha. And now if this is a minus, this is going to be a plus, so we're going to add those. So we're going to have cosine of 50 degrees plus 10 degrees. Oh, I went right there in one. And of course, what is that? Cosine of 60 degrees. And we already said over here that cosine of 60 degrees, that's going to be this horizontal distance right there of exactly 1/2. Isn't this cool? Excuse me. Okay. Now, same thing with some radians, right on. And I see a sine, cosine, cosine, sine. So here we are below right here. Okay, also, 5 pi over 12, pi over 12, those aren't my key angles on the unit circle. So let's visualize. Okay, well, 5 pi over 12, that would be over here in quadrant 2. Oh, I started with the, oh, excuse me, I did that wrong here. 5 pi over 12, well, this is 6 pi over 12, so 5 pi over 12 would be right here, and then pi over 12 would be right there. And we do not know the outputs of either of those right there. But isn't 5 pi over 12 plus pi over 12, isn't that 6 pi over 12 or pi over 2? And we know the coordinates of this point right here. The x is 0 and the y is 1. Okay, so let's work backwards again. So we're going to use sine of alpha plus beta. Sine of, that would be 5 pi over 12 and pi over 12. And of course, this is a plus, so we're adding them plus because the sign remains the same. And that is sine of 6 pi over 12, which we would call a pi over 2. And we already drew this up over here. Sine of pi over 12 is that 1 right there. 1. Okay, one more problem. Oh, I like this. All right, we're going to do a couple diagrams on this one. So, what's the first thing they tell us? Sine of alpha is 4 over 5, and alpha is in quadrant 1. So let's draw a quadrant 1 right triangle. There's your acute angle alpha right there. And let me see, if sine of alpha is 4 over 5, that would make the opposite 4. And the hypotenuse 5. And this is a Pythagorean triple right triangle right there. Wouldn't this leg have to be a 3? Okay, there's a diagram for this first statement. Now let's do a diagram for the second statement. Sine of beta is 5 over 13, and beta is in quadrant 2. So let's draw a quadrant 2 right triangle. Okay, and sine of beta is 5 over 13. That would make, if this is my acute angle beta right there, then opposite would be 5, and the hypotenuse would be 13. And that means that this leg, this adjacent leg right here, would have a magnitude of 12, but we are going in a negative direction. So that's going to be what? A negative 12. Okay, because we have the Pythagorean triple 5, 12, 13 right there. Except we're going in a negative direction, so this 12 must be negative. Okay, so with those two pictures, can we find cosine of alpha plus beta? Well, I think we'd use this top identity right there. All right, so cosine of alpha plus beta is going to be cosine of alpha, cosine of beta. And now think about this. This is a plus, so I need a minus right here. And then I've got sine of alpha, sine of beta equals. All right, so what is cosine of alpha? Well, let's just look at our diagrams right here. I see cosine of alpha would be this 3 over the 5. And then cosine of the beta would be adjacent to hypotenuse, negative 12 over the 13. Minus sine of the alpha is 4 over 5, and that was given to us, by the way. All right, and then sine of the beta is 5 over 13, which is also given to us. But now let's do our arithmetic here to get an exact answer. So do you see a common denominator of 5 times 13, which would be 65? And then I see a negative 36 minus 20 more, that's a negative 56. And there is the exact answer given the information. Sine of alpha is 4 over 5, alpha in quadrant 1, sine of beta is 5 over 13, beta in quadrant 2, and find cosine of alpha plus beta. Wow, cool stuff. Okay, we're going to finish off with a proof here. How cool. All right, so we're going to prove sine of 3 pi over 2 minus x equals negative cosine of x. So right now, based upon the identities that we have learned today, isn't this equivalent to sine of alpha minus beta? Right here. Okay, so let's rewrite that as sine of alpha cosine of beta plus or minus cosine of alpha sine of beta. All right, so start with a sine of our 3 pi over 2. And then we've got our cosine of the x. And now sine remains the same, so if this is a minus right there, I've got a minus right here. And then we have got cosine of the alpha, or in this case, cosine of 3 pi over 2, and sine of the beta, or sine of x. Right there. Okay, now let's see if we can simplify this. Okay, well, sine of 3 pi over 2, isn't that a negative 1? And I'm going to write negative 1 times cosine of x as negative cosine of x. And again, let's visualize it. So 3 pi over 2, there it is right there. And this vertical distance on the unit circle is exactly negative 1. So we got our negative cosine of x. Now what's cosine of 3 pi over 2? Well, cosine of this angle right here, there is no horizontal distance, so that's a 0 times sine of x, which is 0. And we are left with negative cosine of x, which that's what we were looking for. So a little QED right there. And now here's some homework problems. I'd like you guys to do page 373, 1, 2, 4, 13, 15, 17, 21, 22, and 25. And I promise I'll have all of the answers to the even problems posted in Google Classroom. You guys work hard, get really good at these identities, and let me know if you need any assistance. Have a great day.